Newton's third law of motion. An interaction involves a pair of objects or bodies. Consider this block resting on a table. The force of gravity is acting on it. The block is in contact with the table, so it pushes against the surface of the table. This is the normal force exerted by the block on the table. It is labeled as vector nbt. Simultaneously, the table exerts a normal force on the block. If it did not, the book would simply fall through the table. The normal force that the table exerts on the block is labeled as vector ntb. Notice here that the force that the block exerts on the table, vector nbt, is equal in magnitude to the normal force that the table exerts on the book, vector ntb. They are in opposite directions, but note that these are not forces acting on the same object. They are acting on different objects. Newton's third law states that when an object A exerts a force on an object B, the object B simultaneously exerts an oppositely directed force of equal magnitude on object A. Two bodies that interact always exert a force on one another. Two forces are equal in magnitude but opposite in direction. Newton's third law applies to two objects that are interacting. When we consider only one object, there is no interaction, and therefore Newton's third law is not applicable. Newton's first and second laws can be applied in this case. The forces vector Fg and vector Ntb are equal in magnitude and opposite in direction. But that is not because of Newton's third law. We have considered one object, and that object is in equilibrium, hence the two forces are equal in magnitude. We need to apply Newton's third law carefully. Let us take another example. Observe the cannon firing a cannonball. The cannonball is fired due to a force produced by an explosion inside the cannon. This force pushes the ball out of the open end of the barrel of the cannon. Simultaneously, the cannonball exerts a force on the barrel of the cannon. The forces vector Fb and vector Fc are equal in magnitude but oppositely directed. Importantly, they are acting on two different bodies, that is, the cannonball and the cannon. This is according to Newton's third law. The two forces, however, may have very different effects on the two bodies. If we consider the cannonball, there is a net force acting towards the left, hence it momentarily accelerates towards the left according to Newton's second law. It travels far, since its mass is low. If we consider the cannon, there is a net force acting towards the right, hence it momentarily accelerates towards the right, according to Newton's second law. It travels a small distance, since its mass is high. We see that they move in opposite directions and for different distances, but the cause is the explosion and the same magnitude of forces act on each body. The two bodies need not always be in contact with each other. A planet and an asteroid exert a gravitational force on each other. The magnitude of the two forces is the same while they are oppositely directed. It is only because of the Earth's larger mass that the asteroid moves towards the Earth.
Starting to feel it? Now go master it with maskitv.